Hello everyone. During this tutorial video, you will learn a little bit more about the advanced features related to the simulation setup of VINcoSIM. Let's start with the Heatsink and Environment Setup section. If you switch on the Customized Heatsink Definition selector, the simulator will offer you the possibility to define the Foster model of your own custom heatsink by typing in R and tau values. You can add or remove pairs by pressing the corresponding button. During the definition of the pairs, the simulator will display the transient thermal impedance graph immediately. VINcoSIM has the option to override basic engine parameters. The first is the junction temperature root mean square error. The lower the error limit, the more accurate results can be obtained. But this requires more calculation resources. The cycle limit is a defined number of cycles, during which the simulation has to reach a steady state. The lower the cycle limit is, the faster the simulation will be executed. However, the results won't be as accurate. With a larger cycle limit, the steady state can be reached with greater probability. If we move to the Simulation Setup section, you can see that there are different types of additional options. By clicking on the I button near Operation Modes, you will be able to check how a selected operation mode will work in a simulation. Here, for example, you can see that in General Inverter Operation Mode, by changing the COS-phi to -1, the energy flow can be reversed. The Modulation Method selector on the Control tab also has an I button. This will show a detailed description of the theoretical background of the available modulation methods for a simulation. By clicking on the Component Characteristics view, you can check which component characteristics are used in the given stage. Static and thermal characteristics will be displayed on the same page for one function with some basic technical information about the component. Dynamic characteristics are located on another page where the switch on, off, and recovery energy distribution can be observed as the function of gate resistance, temperature, and current in 2D and 3D graphs. Basic details about measurements can be found here as well. When every desired input parameter is set, the simulation can be performed by clicking on the Simulate button.